summarization of data. And it's something that I don't know if it gets full, I think it's proper due course in many courses. To me, summarization of data is the first thing that you do when you get a data set in order to understand your data set and to try to build an intuition for what it has to say about your question before you set out doing statistical tests. Because oftentimes your intuition is good if you produce the right summaries, and it will help you keep you from making mistakes if you do an analysis and get something that doesn't match with what you saw in your summarization. And there are lots of options for every data type and combinations of data types. I'll cover a couple that we use for nominal and ordinal data. The frequency table, also called contingency tables, all this is counting up the different values that occur and providing those total numbers for each variable. It is an alternative to this, the pie chart. Can anyone tell me what's wrong with the pie chart?
And graphic does 50%.
Yeah, so as you pointed out, the graphic shows 50% and the numbers show 87%. But actually the first problem here is that they used a pie chart, in my opinion. As biostatisticians, we never use pie charts. So I don't know, in your final projects and that, don't use pie charts. They're okay for newspaper articles. They're nice because they look like pies, but they're not actually that informative. The second problem is, yes, that the numbers don't match up with the numbers don't match up with the graphic. And we can tell that because we basically have here a frequency table, the 8713, and we also have the graphic. This is what so-called one-way frequency tables look like for a single variable, and all it is a count of your number of records that have each value of your nominal or ordinal variable. So this first one, this is a binary or dichotomous variable. The second one would be a categorical or an ordinal variable because it's mild, moderate, severe, and does have an order. What you can show in a frequency table, you can also show in a bar chart. And a bar chart is our preferred alternative to the pie chart. The reason that that statisticians and I think usually epidemiologists prefer a bar chart is because it's more informative. Because you can actually look across any one of these bars and read the number, and you can very easily compare to see which is higher than the other, which is very difficult to do with a pie chart. So when we have two nominal or ordinal variables, we can make a two-way frequency table, which this is an example of. So instead of just having one row or one column, as before, we have rows and columns. And it's just adding up the number of records with each pair or each possible combination of these two variables, treatment and pain. If you have three variables, then you would have to do this as a series of two-way frequency tables. These sums that I've put here in the margins, these are called marginal totals. And that's a terminology that I'll come back to. In this case, they're marginal totals. I'll also talk about marginal probabilities, which is something that sounds fancy, but is actually simple. That would just be, there are 100 patients here, it would just be each of these numbers divided by 100 to provide marginal probabilities instead of marginal totals. Marginal, that's it. We just say that because you write it in the margins of a frequency table. Keep on getting a little bit ahead of myself, forgetting to advance the slides, but there they are, the marginal totals and the marginal probabilities, being the probabilities being 50 over 100.5. So the marginal probability of having received the treatment in this fictitious clinical trial is 50%. And the marginal probability of experiencing mild pain is 20%. And that's regardless of whether you receive the treatment or the control. So again, anything that you can display also in a two-way frequency table, you can also display in a bar chart. And one way is with this so-called stacked bar chart, where we're showing treatment and control as separate bars, and then shading differently the level of pain reported for each of them. So you can look at this and see, okay, there are 50 each who receive treatment and control. In the treatment group, it's equal, more or less, numbers of people reporting mild, moderate, severe pain. And in the control group, there's a much bigger chunk of people reporting severe pain. So it's a very descriptive, compact description. There's no equivalent of this in pie charts. You can't do a two-way pie chart. The other type of bar chart I should mention that could be used here, but I didn't put in, is the sort of side-by-side bar chart, where instead of these being stacked, this would be 3 bars side by side. Also a valid way to do it. It just shows something different. It's a little harder to count the totals when you do a side-by-side bar chart. I should note also that you could, of course, do this the other way. Just like you can switch the rows and columns of a frequency table, you can switch the rows and columns of a two-way bar chart, just by the way, the order in which you enter your variables into the software. So we could have had 3 bars for mild, moderate, severe, and showed the number of treatments and controls for each of those levels of reported pain.